So coming up next, we wanted to move on to games. We wanted to step out of the film and TV world and talk a little bit more about video games. And for those of you who haven't been living under a rock for the last little while, you're probably aware that there's a new console cycle revving up, and everything's going to change, and all those little boxes you've got underneath your entertainment centers are going to have to shift into something new very soon. So we wanted to get someone to come out and talk a little bit about that. So I'd like to introduce Habib Zargarpour, he's been in the film industry for 12 years, working at places like ILM. He got 2 Academy Award nominations for Twister and for The Perfect Storm. He then moved on to games, where he's been for the last 10 years, and now he is at Microsoft Game Studio, I should say. So again, I'd like to invite Habib Zargarpour to come out, and he's going to talk about some of the new games for Xbox One.
Thanks, everyone. It's been a while since I've been on stage at the user group, but it's great to be here and see all of you. I wanted to talk to you about some of the work I've been up to recently. We're going to start showing you basically 4 games, the last 2 of which I've been involved with. But there's a lot of exciting things happening on Xbox One, which is going to launch in November. And there's a lot of amazing work being done graphically. So let's roll the video. I focus on visuals on Xbox One titles as my role at Microsoft Studios. Everything you're going to see is in real time. Xbox One has a lot of power, a lot of memory, and ever since I've moved from film to games, I've been wanting to pursue basically beating the film guys and giving them a run for the money, and trying to match that quality. So it's really exciting to see more and more powerful boxes. The Forza team, the Turn 10 team, did an amazing job showing imperfections. For example, the orange peel in the paint, scratches on the brake pads. They've been able to really push the box and do an amazing job with resolution and frame rate. And so that's going to be an amazing title to look forward to. Something completely different, Project Spark. Started as an experimental way of having people be able to make their own games. So obviously the content is originally created in Maya, but once you create your content, then currently the team has been able to generate all of these games by just giving this engine to different people, and each one of them comes up with their own game, and they're able to bring in the content from Maya. Next up, you're going to see a project done at Remedy. They're in Finland, and you know them for their work on Alan Wake, which was very touted for its storytelling. And you can see the work they've been up to on Quantum Break.
Seconds, Jack.
Okay.
Let go of me!
I'm not gonna hurt you, but I can't let you go! Doctor, you're the only one who can fix this. I don't know the science, but I know the guy who murdered Will is using you.
Paul said people would try to steal our research.
Hard way.
It's collapsing. Move it! Move! 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 Ah!
So some amazing quality to expect. I wanted to share just a bit of a background on Project Ryse that I've been working on very closely for the past 2 years over with Crytek in Frankfurt. And some of it started with trying to design a character that really stands out and really bears that Roman general aura. And so we started with some traditional designs that were still a little out of the box, but it wasn't quite innovative enough. So what we decided to do was we took some Art Deco, American Art Deco, and mixed it with the Roman design to have a really fresh look on what Rome can look like. And so you see a traditional armor over there on the left, and then what we were evolving for Marius, the main character, and this is what we ended up with. You can see the influences of Art Deco in and around Rome and in and around armor, and there's some spectacular work being done in terms of environments and lighting. So I've been really, really excited working with the Crytek team and very excited about this game launching with Xbox One in November. And so this allows me to introduce to you Chris Evans, who is an art technical director at Crytek. So he's the technical guy who's also an artist and makes this stuff possible. And he has a background in film as well as games, just like me. He's a hybrid. So he used to work at ILM on Transformers and Avatar. And he's going to be showing you some amazing stuff. So, and he's really fantastic to work with. So Chris Evans, take it away. Thank you, everyone.
Thanks, dude. Hi, guys. Well, I just quickly wanted to go over some of the pipeline work we've been doing on Ryse. If you haven't really heard of Ryse, I'll do a quick background on it. After Crysis 2 at Crytek, we decided to break off a small team of people and start working on Ryse, which had been in development for quite some time. But it was at that time that we decided that we were going to work with Microsoft and we were going to work on some next-gen hardware. And from the first kit, we've been working on the hardware, and we've been trying to get everything we can out of it. As if that wasn't enough, we decided that it would be a really good time to rebuild some of our pipelines. So we rebuilt a lot of our pipelines from scratch, our character pipeline, our destruction pipeline, and that's some of the stuff that I'm here to talk about today. So far, with our pipeline development and everything, we're about 1.5 years into development of that, and it's kind of, we have the elephant in the room is our looming deadline, which is coming up close. Everybody's crunching back home, and they're gonna be looking at me talking here and be like, yeah, But so yeah, we're a launch title. We're out in November. We were one of the playable games on the floor at E3 on hardware. So I'm gonna talk about the character technology a little bit. From day one, we had this kind of mantra in the company that was play the cutscene. So we want you to be able to play the cutscene. Your character is the same character. It's the same rig that is in the cutscene. We only have one rig on Ryse per character, that is. And that character, whether he's in a cutscene, out of a cutscene, the director, Peter, he wanted to be able to zoom up close to a character in combat, in executions. And what that meant is we had to have cutscene fidelity everywhere. So it meant really rethinking our character pipeline and how we're going to do that. So this was our first Maya project at Crytek, and we built a Maya pipeline around some of the things that I just talked about and anticipating some of those and knowing that that's where we want to go as a company in the future. It was our first big virtual production project. We worked with the guys out at Imaginarium, and it was, sometimes we had 12, 13 actors on stage all together, suited up, head cams, everything, acting off of each other, Peter directing the scenes, virtual camera, that piping into the engine, everything. It was a big data back end for us. But that's kind of the break for us, is that this is our first really big story-driven game. And there's tons of hero characters. At Crytek, with Crysis, we have the masked protagonist who shoots a bunch of masked guys. There's some people with faces, but we just weren't really ready for a project of this scale and this scope with this much emotion that has to come across from the characters. I mean, Peter really wants to see what he sees on stage. He really wants to see that in the actual game itself. So if we could roll the gameplay video. This is all, everything you see here is running on Xbox One.
Attention, lads! The brave man tastes death once. Cowards, 1,000 times over. And we have already spilled barbarian blood. And we know they bleed as we do. Ready! On me! Move! Advance! Our fleet be destroyed! We must take out that tower! Shields! Arrows! Shields! Hold! Pillars! Arrows, men!
So that's kind of Ryse in a very bloody nutshell, I guess. So I just quickly wanted to go through the character pipeline pretty fast, talk about some of the decisions we made. We built a kind of a modular rigging pipeline. We break everything down from characters to character parts to rig parts. Everything has metadata. It's all generated by Python. I think it's about 7,000 lines of Python for a character. We really needed to focus on outsourcing. Most of the project, there was only 2 people rigging for all of the characters, and we have like over an hour worth of cutscenes and a lot of stuff. So we really needed to work on finding good outsourcing vendors, figuring out how can we still innovate while we're outsourcing. We like to say that we're kind of building the plane while we're flying it all the time, being a technology company, but we really had to look for a long time, and we found a great partner in 3Lateral, and we've been working with them on a lot of the outsourcing, and it's really allowed us to kind of build this future pipeline where a year ago I would have said we will never outsource rigging because it's just not something that's possible. It's not something we can do. We also had to come up with a scene description file format, which, when you have 12 people on stage all talking together, you really are generating tons of data, and you need to be able to record the props, the cameras, what character, what head is on who's talking, what actor is playing this guy, and it's just a kind of a mess full of data. This is just I wanted to show some rig porn here. This is a quick overview of some of the nodes that we built just for character part, rig part, and it allows us to use kind of one tool set across all parts of the character, all characters, and we don't really have any kind of rig-specific tools anymore. And this allows us to, with games, you have to be able to batch all of your assets. However, we can have, I think it's 1,400 nodes when we traverse those networks, so we have kind of a front end. And this shows all of the rig parts and character parts that make up a Roman. And I think most of these are actually written by Riem Toulan. We call her Speedy Gonzalez because she's like a force to be reckoned with when it comes to rigging. But I mean, we only really have 2 or 3 people working on a lot of this pipeline stuff. So the Marius that you saw, he has about 150,000 triangles, and that's with all of his armor, all of his swords, everything. He has about 500 deforming joints, 260 of those are in his face. He has 230 corrective blend shapes running on his face at lot 0, and that stuff is all running on Xbox One. These corrective blend shapes just serve to keep the joint rig on model at all times, because we have a pretty thorough fact scanning process that generates a lot of this data. And you also saw some cloth, leather, armor simulation. We have a runtime wrap deformer, so it's a bit more of like a film pipeline, so we can just focus on a good sim mesh and not have to worry about the render mesh. I'll breeze through some of the facial tech because I'm running out of time, but we updated our facial pipeline to allow for 8 scanning influences. And if you look at the face here, we now update the normals on the face for blend shapes and for joint translation and some of the things that game engines don't do really well. In order to get all this running on Xbox, we have about 260 joints, 230 shapes at the lowest, at the closest you get to the character. If you zoom in a like cutscene or in any part of the game, whenever they zoom in, that's what you see. And then we kick the shapes, and then we kick more joints, and then we kick down to even less joints at a further distance. And that's kind of how we get it all running. But all characters share the same rig modules, the same stuff, they're the same fidelity. So the barbarians have 260 joints on their face. And all of this data, wrangling it, was just a pretty big problem to solve. And going on to another problem, I'm going to quickly talk about the destruction pipeline. So at Crytek, we've always done a lot of destruction. It's something kind of near and dear to our hearts with Crysis franchise. And it can be a pain. We really wanted to see how can we make this a lot easier. So we've really switched to a cache-based pipeline now. And if we could show that video. So this is the sail that you saw tearing while the guy was playing in the game. This is running on Xbox One. This was actually created by Sascha Herford in Frankfurt. He's like our master of destruction. And to see something like this running while the player has control and while he's playing the game, that's what Next Gen is about for us. So a little bit more about the pipeline and the format. It basically imports Alembic. It has no engine-specific markup. The average file size is about 10% of the ABC original. We're compiling it into our own format, which is the geom cache. It renders as efficiently as static geometry in the pipeline. The user can say how lossy he wants it to be when it comes in. Usually that's dependent on the size that the person's working with and stuff. It also supports instancing, streaming, buffered playback, a lot of stuff that we really needed to get this running on Xbox One and to allow us to use it everywhere. In that video, we're using it all over the place. There's sometimes where we just don't like the way one of our cloth things is working, and we just cache endcloth, bring it in. The little flags that drop down, a lot of those are endcloth, and it's just a really good way that allows us to go in. And Sascha, the guy I mentioned before, he made a really good pipeline video just showing how easy it is with one click to get something in. So this is a siege tower that he's actually was working on this morning, and he sent me this video. So he makes this siege tower, and now he needs to get in the game engine. And previously, that would have meant like, oh, well, I need to make one joint per rigid piece, and I need to figure out how I'm going to skin this. And we would spend so much time just figuring out how are we going to get this over into the game engine. So now he's going to use the pipeline cache export to save an Alembic file. And I think he's going to cut that part out of the video. and then he's going to pop into the engine, and he's going to import it. And when he goes to import this, a dialog pops up, and it just asks him, what was, he blew through that because we have presets, but it says, what was your up axis, some things that aren't stored in the file itself, and he just had his preset, he says go, that was also what kind of compression, how lossy, and now here it is. It just pops into the game engine, everything looks great, and it just collapses kind of under its own weight. And it's stuff like that that used to be so difficult for us to do, and it just really makes a difference to be able to drop something like that in with one click. So it really allows us to iterate much faster. We can turn stuff around much, much faster. We really get to focus on making the art and not focus on getting the art into a game engine, which can really be a pain sometimes. Also, it allows us to work with VFX vendors. We can send stuff out. This is the first project where we've outsourced destruction, large destruction events. We're working with multiple different vendors to do that, and using ABC to go back and forth, it allows us to do that really easily. We can also try new things really fast. I have a quick video test I wanted to show. This is the Next Limit's rigid body engine, and this stuff, all of this jointing, I didn't joint any of this together. This is all jointed procedurally based upon how close the objects are together. And I was talking to Gus over at Next Limit, and this is just amazing for us because it really helps us do these kind of jointed structures, and it's really, really fast. And because they support Alembic and they have a Maya plugin and everything, it's very, very fast to get something like this in the engine and test new stuff. So that's kind of my takeaway, is that I feel like new hardware is allowing for more feature film practices. Some of the fax rigging, the facial rigs that we have running at runtime, this is stuff that you would never see on a game previously. The same with the Alembic cache implementation, our geom cache implementation. Also, like I said, this is our first Maya project, so I feel like you can switch to Maya in a production cycle, and even in a relatively short production cycle. And that it's maybe not as easy if your assets are Z up, but that could be a small problem. But I just want to say thank you for having us out to show our fledgling pipeline, and wanted to thank the guys back home who made all of this stuff possible. Back to Sean.